The way we live, where we live, the things we do, even the kinds of food we grow and eat are all affected by climate. The history of man could be written in terms of major cycles in climate, sharp changes in temperature and precipitation that forced the people of ancient times to migrate from continent to continent, and that even today help determine whether a nation thrives or perishes. Scientists believe these cycles may be the most important but least understood factor that shapes our world. We call them the climate factor. A 100 million years ago, the North Pole was free of ice. Earth was warm and balmy. Swamps and warm, shallow seas covered much of the land. Millions of years later, the Earth's climate changed. Sheets of ice formed at the North and South Poles. 18,000 years ago, the island of Manhattan lay at the edge of a mile-thick sheet of ice. Glaciers covered much of North America, Europe, and Asia. 10,000 years ago, some warming took place. The glaciers retreated from Europe and North America, and man moved northward. 5,000 to 7,000 years ago, the Sahara was moist and fertile. Man farmed there. But cooler and drier conditions came again. The region became a desert. The people moved eastward. 1,000 years ago, when Greenland was warmer than it is today, the Vikings used it as a base to explore the oceans as far away as North America. But 4 centuries later, the climate turned cold once again. The Viking colonies vanished. The Little Ice Age had begun. From 1890 to 1930, the world was warm and moist. The American Midwest was fertile. But in the 30s, the rains failed. Farms turned to dust. Many people of ancient times believed the gods of sun and rain controlled the weather. Today, we track conditions with the technology of modern science.
Close to the land area as indicated by Channel 2 radar.
Using these tools, meteorologists routinely issue forecasts for a day or a week.
You're seeing right here around the Galveston Island itself that was responsible for the tornado just reported a couple of minutes ago.
Meteorology is an old art. What is relatively new is the scientific concentration on climate. Climatologists study long-term averages of temperature, precipitation, snow cover, and wind behavior. They analyze the chemistry of the atmosphere and gather ocean and upper atmosphere data over decades and centuries. Climatology has radically changed our view of the world and the way we live in it. One of the deans in the field is Dr. Helmut Landsberg of the University of Maryland.
Climate is, of course, the sum of all the weather events that take place in an interval of time and that are related throughout the globe.
In Dr. Landsberg's view, a look at the world of climate starts with food, the basis of life, man's ability to feed himself.
The most important influence of weather is on crops. And bad crops are related to bad weather. That's axiomatic.
We take for granted the piles of fruit and vegetables in our supermarkets. Much of it comes from the Southwest and Midwest, regions with long growing seasons, but low average rainfall. Charles Stockton, a meteorologist and hydrologist at the University of Arizona, has studied the problems of the Southwest.
The next time that you're preparing or eating a nice green salad, think of the amount of water that was necessary to raise the vegetables that are going into this salad. Think of the amount of water that's necessary to raise lettuce, green peppers, tomatoes, radishes. All of these items are large water consumers. Without water in the Southwest, where we can raise 2 or 3 crops of these items per year, these vegetables will not be available in the market for you to buy, for you to purchase in order to make your green salad. The majority of our water in the Tucson area comes from groundwater. This water is being produced from probably somewhere around 400 to 500 feet. At that depth, the water is roughly 5,000 years in age. Presently, we are operating in a deficit as far as groundwater goes. That is, we're actually using more water than is being replenished annually.
The present plan is to transport water from the Colorado River to Tucson for agricultural, municipal, and industrial use. But climatologists believe that this may prove only a temporary solution. If the Arizona climate becomes slightly drier, then even the importation of water would be insufficient. Midwestern farmers such as John Klosterman grow different crops from those raised in the Southwest, but their problem is the same. Water is short. Klosterman grows corn at David City, Nebraska. Corn is a wetland crop that requires about 30 inches of water per year. In an average year, David City gets 24 inches, 6 short of what is needed. To make up the difference, Klosterman drills down into the Ocalala Aquifer, a vast underground water reserve.
We're not really irrigating here as much as we are mining water. The wells are 300 foot deep. The water will stand in the wells at about 150 foot, and when you start pumping, will immediately draw down by a good 30 feet. But then that pumping level should remain fairly constant if your water supply availability underground is constant. And to tell you what kind of water shortage situation we're getting into around here, we're now pumping from in excess of 200 feet. So we're starting to run out. And the only way this water gets replenished is by rain falling on the land. When you've got what amounts to 5 out of 6 years of constant drought, you're just taking out far more than it ever finds its way back. There is no way in God's name that we can keep this up year after year after year.
One answer may be the development of rotational crops, more suited to the natural climate. Dr. Norman Rosenberg, an agricultural meteorologist with the University of Nebraska, is exploring the possibilities.
Primarily, we're trying to find out how to get the most plant productivity or the most yield for the least water. We also are working in this field on a new technique, modifying the architecture of the plant, changing its form in order to adapt it more effectively to the environment, particularly to the stresses of the environment, the droughts, the strong winds, the hot spells, and so on. Microclimate manipulation is one of the few things the farmer can do about the weather.
Some farmers also are using technology to gain instant access to climate data. Using a telephone modem that links him to an integrated computer network called AgNet, a farmer sitting at a computer terminal can call up daily data and past climatic averages. The printout gives him the information he needs to develop a planting and irrigation schedule. It may even help him lower his costs and increase farm productivity. This would translate into lower prices at the market. Access to such climatic data soon may also allow us to give other nations advance warnings of drought conditions, warnings they need to help them avoid famine. Climate is not just a concern down on the farm or at the supermarket cash register. Our cities, our homes, our fuel and water supply, even our jobs, and our ability to function as a productive nation are affected by climate. Peter Levitt, a vice president of Weather Services Incorporated, has given much thought to the way man adapts to climate.
Since the dawn of civilization, man, as all other creatures, has had to adapt to the changes in the climate and his environment that occurred naturally during the thousands of years that he was developing. But man, as usual, went one or more steps further than simple adaptation, and he has started to modify his environment, clothing, the discovery of fire, building of shelters. All of these things enabled him to live in areas where he might not normally survive. For example, take Minneapolis in the wintertime. I don't think we'd see as much hustle and bustle going on in the upper Midwest as we do today if it weren't for the fact that man is capable of altering his local climate by producing heat. In recent years, we've seen a large influx in the populations in the southern part of the United States. However, this would not have been possible if we didn't have air conditioning. Now just try to imagine an area like Las Vegas in the summertime without air conditioning. As a result, the utilities now find maximum loads now occur in the summertime, whereas these loads used to maximize in the wintertime, on the coldest days of the winter, and of course that represents the rapid increase in air conditioning facilities that we're using to locally alter our environment. Unfortunately, you don't get this alteration of climate for free. It requires a trade-off. It takes energy to change the local environment, and the energy costs.
The use of climate data in energy production begins with the design of offshore oil and gas platforms. John Wilson, supervisor of the Meteorology Department of Stone and Webster Engineering, oversees the designing of oil rigs.
Climate is important in the engineering and design of structures and buildings because it causes various trade-offs to take place between economics and engineering. For example, an offshore oil platform will be designed to withstand the highest wind speed that may occur over the life of the platform. That may be 50 years, that may be 60 years. If you picked the wind speed that occurred in 100 years, you might have an over-design condition. If you picked only the highest that occurred in 10 years, your design wouldn't be strong enough.
Another step in the energy chain is the forecasting of how much energy will be needed to heat homes, schools, and offices, and to keep industry humming. Joseph Bernica of the Massachusetts Office of Energy Resources explains how demand estimates are prepared.
And it is a 30-year average that details what they refer to as the degree day units, that is the average temperature below 65 degrees on that particular day. Many of the larger companies have it, as a matter of fact, entirely computerized. In 1977-78 heating season, they used 1,500 gallons of home heating oil to heat an average two-bedroom home. This year, using the 30-year averages, we expect that same homeowner to use approximately 900 gallons.
The energy chain ends with consumers, the homeowners, businesses, and industries that make up a community. Each must weigh the effects of climate upon the location, design, construction, and cost of operating a home, office, or factory.
Two important climate factors that go into designing buildings to minimize energy usage are the amount of wind at a site and the amount of sunshine that a particular location might receive. One of the most important climate factors in a northern setting would be snow load, the weight of snow and ice on the roof of the structure. In the south, it may be high temperatures because that will affect the air conditioning.
Climate also is a factor in flight. Airline routes and airport sites are selected by studying climate histories of average wind speeds and directions, and the number of low visibility days at a particular area or along a potential flight pattern. Engineering firms that use vast quantities of climate data, such as Stone and Webster in Boston, obtain it from the National Climatic Data Center. John Wilson of Stone and Webster describes the information he purchases.
These climate data are the result of hourly observations taken at several hundred National Weather Service stations throughout the United States. These are all of the observations of temperature, humidity, wind, precipitation, cloud cover, sunshine, and these data are summarized by the National Climatic Center into long data tapes covering maybe 30, 40 years of data. There will be a tape for Boston, a tape for Chicago, a tape for Los Angeles, and all of the other several hundred stations. The engineering meteorologist will take a data tape for a particular city, use it with one of his own computer programs to prepare statistics of a particular weather parameter, such as wind speed. We could use this on anything from a major construction project, such as a power plant or a refinery. We could also use the data for something very small, such as looking at wind speeds for a wind turbine.
Construction of the Washington, D.C. Metro Rail, one of the nation's newest rapid rail systems, was a major project that required a variety of climate data. Data on flooding, snowfall, and temperatures. In some locations, the system runs close to the Potomac River, so data on maximum flood levels, the highest that had occurred during the past 100 years, were needed to determine where to locate these routes and to decide how high subway openings should be. The system uses a continuous welded track. Therefore, 25-year records on maximum temperatures were needed to construct rails that would not buckle or break when they expanded in the heat of summer or contracted during the cold of winter. Engineers on such a project also use data on maximum wind speeds. That tells them if special shielding will be needed to protect elevated trains. And it aids in the design of elevated stations. Snowfall records were necessary for determining how many work trains and snowplows would be needed to keep the system running during a storm. These are a few of the sophisticated ways in which we are now using climate information. But the search for more data on past climates continues. It has taken climatologists into the depths of the ancient forests in Arizona. There, in the cores of certain trees, they look for traces of rainfalls and temperatures from decades or even centuries long past. Tree rings are like diaries of climate cycles up to 3 centuries ago. Dry years of stunted growth, wetter years of rapid growth. These cycles of the past are clues to the future. Harold Fritz analyzes tree rings at the University of Arizona.
The glimpse that we have in the 20th century is too short, too limited a view when you consider that the climate for the last few hundred years, and then if you go thousands of years, was quite different in some regards from the climate of today.
Climatologists compare tree ring records with other ancient climate diaries. Carbon dating of fossil oxygen in the cores of sediment brought up from deep below the ocean floor indicate variations in temperatures thousands of years ago. In Greenland or Antarctica, ice cores drilled from glaciers reveal the temperature of the layers of prehistoric snow from which the ice was formed. Climatologists use enhanced satellite observations from space to measure the Earth's energy balance. Harold Yates is acting Deputy Assistant Administrator for Satellites at the National Oceanic and Atmospheric Administration. He talks about the need for these observations.
The Earth energy balance of the entire globe can only be measured by a truly global observing system such as a satellite. The satellite can provide you with measurements of global distribution of clouds, snow, and this radiation in, radiation out balance called the Earth energy balance.
Other scientists who are stationed at the South Pole, Alaska, Hawaii, and Samoa are studying another factor that may affect the climate of the future: the increase in carbon dioxide in the atmosphere. There is evidence that carbon dioxide produced by man may be altering the climate by changing Earth's energy balance. Some call it the greenhouse effect. Dr. J. Murray Mitchell is senior scientist for the National Environmental Satellite Data and Information Service. He talks about the greenhouse effect.
One of the ways in which man's activities might influence future climate is by the prodigious quantities of carbon dioxide gas that are released whenever we burn natural gas, gasoline, coal, any other material like that, fuel, that is mined out of the ground. We believe it's very realistic to expect that within the next 100 years, the amount of carbon dioxide naturally in the air will be doubled by all the fossil fuels that we will be burning in the meantime. A doubling of carbon dioxide may very well warm the Earth by something like 2 or 3 degrees Celsius. The basic idea is that carbon dioxide is transparent to sunlight pouring down through the atmosphere to warm the Earth. But it is not transparent to heat radiation, which is welling back up from the Earth and trying to dissipate that heat into space. So it's like the glass in a greenhouse, where glass is also transparent to sunlight coming through, but it's opaque to heat radiation trying to escape back out of a greenhouse.
If the global temperature rises, it would shift the climatic belts on Earth. It would change the rainfall patterns. It would change again, it would influence again the crops. And actually we cannot predict with any precision what would happen. But there are a lot of people working on that problem.
There are also a lot of people investigating other climatic problems. The United States Congress greatly expanded our capabilities for conducting climatic research and data gathering when it created the National Climate Program. The program generates and disseminates vast quantities of climate information. It assesses the impact of climate and provides research and prediction. Climatologists are now working on questions that have mystified man since the dawn of history. Now, with new tools and technology, we may find answers to those questions. Answers that will help us make wiser decisions about water and energy resources, about economic planning, urban development, production and trade. Decisions that affect food, jobs, homes, transportation, every aspect of our lives. Decisions that depend on the worldwide effort to understand the climate factor. Swamps and warm, shallow seas covered much of the land. Millions of years later, the Earth's climate changed. Sheets of ice formed at the North and South Poles. 18,000 years ago, the island of Manhattan lay at the edge of a mile-thick sheet of ice. Glaciers covered much of North America, Europe, and Asia. 10,000 years ago, some warming took place. The glaciers retreated from Europe and North America, and man moved northward. 5,000 to 7,000 years ago, the Sahara was moist and fertile. Man farmed there. But cooler and drier conditions came again. The region became a desert. The people moved eastward. 1,000 years ago, when Greenland was warmer than it is today, the Vikings used it as a base to explore the oceans as far away as North America. But 4 centuries later, the climate turned cold once again. The Viking colonies vanished. The Little Ice Age had begun. From 1890 to 1930, the world was warm and moist. The American Midwest was fertile. The way we live, where we live, the things we do, even the kinds of food we grow and eat are all affected by climate. The history of man could be written in terms of major cycles in climate, sharp changes in temperature and precipitation that forced the people of ancient times to migrate from continent to continent, and that even today help determine whether a nation thrives or perishes. But in the 30s, the rains failed. Farms turned to dust. Many people of ancient times believed the gods of sun and rain controlled the weather. Today, we track conditions with the technology of modern science.
To the land areas indicated by Channel 2 radar.
Using these tools, meteorologists routinely issue forecasts for a day or a week.
You're seeing right here around the Galveston Island itself that was responsible for the tornado just reported a couple of minutes ago.
Meteorology is an old art. What is relatively new is the scientific concentration on climate. Climatology. Scientists believe these cycles may be the most important but least understood factor that shapes our world. We call them the climate factor. A 100 million years ago, the North Pole was free of ice. Earth was warm and balmy.